Hello, I'm Aaron with Period 6 Physics at Oakland Tech during the 21 to 22 school year, and I'm going to talk about forces that act upon a rocket. So right now, the forces are balanced in all directions, and this is because the force of Earth gravity is pointing downwards, and the opposite but equal normal force, which always opposes gravity, is pointing upwards. This balances the system out and leaves the rocket stationary on the launch pad. When I start the ignition sequence, the thrust from the rocket engine will increase the vertical velocity, and as you can see, the rocket moves upwards. The forces are unbalanced now, as the applied force emitted from the rocket engine pointing upwards is greater than the force of gravity pointing downwards, causing the rocket to gain altitude. Another thing to mention is the air resistance force that is present while the rocket escapes Earth's atmosphere. The force of air resistance is a form of friction. Friction is always opposite to motion, or the applied force, which in this case is the thrust from the rocket engine. As the velocity of the rocket increases, it experiences harsher resistance from the air until it breaks free. Now I will be talking about energy that is present in a rocket. At rest on the launch pad, the rocket has no gravitational potential energy. This is because the rocket has a height of 0 and can't fall down any further. However, there is chemical potential energy present in a rocket fuel because the fuel's chemical energy converts into work and mechanical energy using a combustion reaction to ignite it, which moves the rocket up and thus increasing the kinetic energy of the rocket. When a rocket runs out of fuel before it escapes Earth's atmosphere, the kinetic energy is decreased and gravitational potential energy is increased, as it now has a potential to fall back down to Earth. Soon after, the kinetic energy is increased once again until it hits Earth's surface.